Now for some smoke and mirrors. As promised, this video will demonstrate how to construct an interferometer at home in order to duplicate the experiments in the previous video, Crackpot Physics at Home Interferometry and Quantum Challenge. Roughly speaking, an interferometer is any device that separates light and then brings it back together to create an interference pattern. They are used in everything from astronomy to chemistry. However, the interferometer in this video is only good for performing the previously mentioned experiments. There are other videos on the internet showing how to make simpler and less expensive general interferometers. The laser for this device should be extremely low powered, such as an off-the-shelf laser pointer. Once again, it should be mentioned that laser experiments should only be executed by adults or under the supervision of adults who are familiar with laser safety. This is what it will look like once it is constructed. Some of you may want to beef up or improve on the basic design I'm going to give you. Here is what that diagram looks like. The shield makes it absolutely certain that the paths remain separated until after passing through the slits. Actually, you can eliminate the shield by placing single slits in each of the paths prior to the two final mirrors, which will now act as Fresnel mirrors. The distance between the beams at the mirrors rather than between the slits and the distance to the mirrors are now the controlling parameters. Some of the things you will need are front surface mirrors like this. 1 inch is a good size. You will want the square mirrors and not the round mirrors. The aluminum surface mirrors cost close to $15 and are better suited to this than the silvered mirrors, which are twice as expensive. Since 6 to 8 of these mirrors are needed plus hardware, you will need to be very interested in seeing these experiments yourself to make the investment. The front surface mirrors should be handled with gloves, as the oils and moisture on the fingers will tarnish them. Another important part is the beam splitter. A half silver mirror is commonly used. It reflects the bottom half of the beam and allows the upper half to pass on through the glass. You can achieve the same results by bringing the top edge of a front surface aluminum mirror half the way up into the beam. In both cases, extraneous vertical diffraction also occurs, less with the half silver mirror, but is not an issue in either case. This is a beam splitting filter. It polarizes the light differently, which can produce its own interference pattern. Not recommended for these experiments. This is a non-polarizing beam splitter. It is expensive and not necessary for the mentioned experiments. However, it is sometimes required by some for acceptance of the results. 2 mirrors mounted perpendicular to each other is my favorite beam splitter. Keeps the number of reflections equal for both paths. The laser has to be repositioned to intercept this beam splitter head on. As a control, I usually duplicate all of my experiments with multiple types of beam splitters. Of course, you will need a means of mounting the mirrors. You can use a bolt with a diameter twice the thickness of the mirror. Cut the head off of the bolt and then use epoxy to glue a plate onto the side of the bolt near the end and extending past it. The mirrors are usually 3.2 millimeters thick, which means a 1/4 inch bolt is about right when you factor in the glue film. Now, if you superglue the mirror onto the plate, the front surface of the mirror will be in line with the center axis of the bolt. Only use a small drop of superglue, as you may want to remove the mirror at some point in the future. This is a typical right angle bracket that you can find at most hardware stores. This one is 4 inches, but you can use a smaller one if you use jam nuts instead of full nuts. Use the existing holes as a guide and drill a larger hole the diameter of the bolt. Anything can be used to assemble a mounting tray, but metal angles with existing holes make it easy. If you enlarge the hole holding the bracket to the same size as the bolt holding the mirror, you will only need to carry one wrench size. You will need to construct about a 1-foot square with one leg extended to support the laser. If you use 2 nuts between the mounting tray and the bracket, you can easily adjust the height of the mirror. Now you have gimbal mirror mounts that allow you to rotate the mirrors horizontally and vertically while the center remains in the same position. Because the light will be directed near the outside edge of the last 2 center mirrors rather than at their center, you need to be a little more creative with their mounting brackets. The gap between the center mirrors can be reduced if the mirrors extend beyond the plate that they are glued to. This is a pick-off mirror. It has a beveled edge, and when creatively mounted, the gap between 2 of them is eliminated. You also need to be creative with the brackets holding the beam splitter and the laser. Next, you will need a shield positioned between the center mirrors. Any thin metal supported by an angle will work nicely. The shield length required can vary greatly depending on the experiment being performed. The easiest way to attach the double slit at the end of the shield is with a cutout T-shaped bracket. The double slit plate can be clipped to the bracket, and the bracket can be clipped to the shield. Some of you may want to extend the bottom support angle for the shield, construct a framework to hold the slit plate. Here again is the diagram for this setup. Here again is what the final setup looks like. I suspect that considering the time and expense involved with these experiments, that very few will be interested in doing these experiments at home, even though it has been shown to be possible. The mounting trays, mirror supports can of course be bought from physics supply companies, but are expensive. However, those of you who are physics students and professors probably have access to this type of equipment and are positioned to perform precise cataloging of all conditions, which is what the initial tertiary experimental results cry out for. I hope you have as much fun with this as I did.